everyone, welcome back to the channel. Today we are tackling a classic LeetCode coding interview problem, counting the number of valid triangles that can be formed from an array of side lengths. We will break down the problem, discuss brute force and efficient solutions, and analyze time and space complexity. Okay, let's start with the problem. Given an array nums, return the number of triplets chosen from the array that can make triangles if we take them as side lengths of a triangle. Let's take a look at the first example. So 2, 2, 3, 4, that outputs 3. So 2 plus 2 is greater than 3, so that's one valid triplet. Then 2 plus 3 greater than 4, so that's another valid. And then 2 plus 3 greater than 4, that's another valid triplet. The constant here is the numbers need to be between 1000, 1 and 1000, and each number would be between 0 and 1000. The naive way is to check every possible triplet. This means 3 nested loops, which gives us order of n cube time complexity. This is very slow for large arrays. We can definitely do better. Let's optimize. We first sort the array. Then for each possible largest side, we use a two-pointer approach to count valid pairs. Let's take a look at the first example. Our first example has the list of numbers 2, 2, 3, 4. So it is already sorted, but if we sort it, we'll get the same numbers, same order. Now, using a two-pointer approach, our left would be the start of the array, start index. Target would be the last index, and right pointer would be one index before the target. So now if we start adding the numbers, then 2 plus 3 is greater than 4, which means anything between this left and right are valid triplets. For example, another 2 plus 3 is greater than 4. So we count, our count is going to be 2. So which means right minus left. So all numbers between this right and left are valid. Now we move right one index to the left. We decrease the right index. The right index now moves to index 1. So if we now add up 2 plus 2, left and right numbers, 2 plus 2, it is not greater than the target, which is 4. So it is not a valid triplet. So the count would stay the same. Now we know that we need to move the left because we didn't find any valid triplets. So if we move the left one to the right index, then left and right are same. So we will end up here. The loop would end here. And then we start over again. Now we move the target from the last index to the one index before. So target moves to index 2. And we move the right pointer to one index before the target. So the right pointer moves to index 2. And the left pointer starts over again. So now when we add these two numbers, left and right, we get left and right greater than the target. So it's a valid triplet. So we increase the count. Now we move the right pointer one index left to see are there any more valid triplets between the left and right. And because left and right are at the same index, so the loop will end and there are no more numbers to look through. So the algorithm will end here. Now let's have a look at the pseudocode. What we have just discussed so far, I have just written it down in a pseudocode. So first we sort the numbers, and while there are at least 3 numbers in the list, we start the left from 0 index, target is the last index, and right pointer is the target minus 1, which is one index left to the target. And while left pointer is less than equals to right pointer, if the numbers left number and right number add up to or greater than the target, add up if we add up numbers left and numbers right, and that is greater than the target, then we increase the count. And the count would be all the numbers between left and right, because all numbers between, now we know the all numbers between left and right are the valid numbers, valid triplets. And then we decrement the right pointer. Otherwise, if the numbers do not add up, add more than the target, then we increase the left pointer to 1 right. And at the end, we return the count. Let's try this in the LeetCode. First, we sort the number. Then we initialize a counter. Then we get the length of the list. Now we loop through the list from the last index until we reach index 1. So last index, we loop until index 1 and we decrement by 1. So we start from 4, then 3, then 2, and we stop there because we need at least 3 numbers to be able to create a triangle, form a triangle. Now we initialize a left pointer and a right pointer, which is target -1. I say I as target. Now we initialize the, now we start a inner loop. And if nums left plus nums right greater than nums target, we increment the counter to all the numbers between right and left because they are all valid now. And then we move the right pointer to left. We decrement the right pointer. Otherwise, we increment the left pointer to 1 position right. And don't forget to return the count. Okay, let's try this out. Cool. Now let's submit it. Great. Now we calculate the time and space complexity of the algorithm. The time complexity would be order of, to sort the numbers, it will take order of n log n. And the outer loop would loop for n number of items. And the inner loop, for each n number, the inner loop would loop for another n times. So the inner and outer loop would loop for order of n square. So the time complexity would be order of n log n plus order of n square, which is order of n square. And the space complexity is order of 1, since we have done the sorting in place and we use only few variables. There are no list or hash set or anything, so the space complexity was order of 1. So there you go. That's how you solve the triangle number problem efficiently. If you found this helpful, don't forget to like, subscribe, and hit the bell for more coding tutorials. Drop a comment if you have questions or want to see more problems like this. Thanks for watching.